Happy Friday, guys. Welcome back to Community Fridays. I'm Yuki and your host for today, Community Fridays. Right. So we have a lot of cool talk lining up for today, ranging throughout the whole team actually. And yeah, so let's get started. First, if this is your first time uh, in one of our Community Friday, just a quick refresher on how it works. So we'll talk about what did we do to make Asimov better, what problem did we face, and how did we solve the problems. And for this particular episode, right, we also gonna feature Richard Franklin from our community who has been working really, really hard on like the training of Locomotion for Asimov, and all of his other project that has been incorporating to Asimov also, right? Um, so for today, we have a full lineup actually from hardware, software, brains, community to career, right? So we'll start out with hardwares with a bit of the update on the manual from my side, then going on with Alejandro on the new design revision on Asimov 1. Then we can move to software where Long will talk about the new Asimov emulator. That's right. We're gonna have an emulator now so that you can actually program on your Asimov, right? Then we'll proceed with Brain, which we are very excited to show you guys the new walking policy live in a stream. Yeah, the team has been working really hard on that. Then we are going on to community with Richard Franklin and Emre to share a bit about our social media effort. And finally, we'll end with the career from Herman to share you about all the open roles at Menlo. Right. Okay, so let's get started. Uh, okay, so let me go first. Yeah, so just a bit of quick update on the manual side. If you guys follow for the past few weeks, you know that we work really hard to make sure that we have like the first grade visualization for the manual. So I would like to gladly say that we have finished basically all of the bottom part of the assembly instruction for the Asimov, right? So this is actually the full assembly of the leg to the pelvis. Uh, and yeah, so right now we are continuing to work on the arm module, torso, and finally, eventually, the full assembly of Asimov. So do expect that by next week we should be able to have the full assembly step. Yeah, so that's it from my side. Next is Alejandro.
Sure, let me share the screen. Okay, I'm gonna do the full screen. Hopefully everything fits there and it's visible. Okay, I'm out now. Okay, so you should guys see just the robots. Okay, so I'm gonna show you guys what changed on Asimov 1. These changes are basically just little improvements here and there to make the usability of the robot easier or improve some assembling steps that were kind of hard. Basically, like little upgrades. And all the units that are being currently manufactured and almost finished for shipping have these new upgrades. So I just wanted to show you this, and in a few hours we will upload the new files into our GitHub repo, so you guys can take a look on the new changes as well. So okay, this is the first version that we had. Let me put it here. Let me put it here. So right off the bat, one of the big things that we add is all the screws. So actually, if I do this, you guys should be able to now we have all the screws in place. So you can take a look exactly where everything goes, how many they are, the type, and so on. So right, if you actually hover into it, oh, there you have it. It's an M4 by 8, right? So that's a big improvement compared to this version where we only had the parts, right? So I think it's better when you guys need to do assembly or checking for repairs or whatever. This is going to come very handy. Okay, so now we go directly into the main changes. You can see here the head, right? These holes were meant for audio. We have some microphones in the head, but unfortunately it was not enough. So one of the big changes is that we add a grid in that part of the head. So now this is two purposes. It helps for ventilation on the head, since actually the Raspberry Pi that lives there gets quite hot over time, and to improve the audio quality, right? So it avoids some echoing with the microphones, and you get a better signal coming from there. Another big change is the handle used to be a separate part, which now is actually embedded into the torso. This is just to reduce the amount of parts that we have to put into the the bomb, and it was kind of hard to assemble these handles since you have to put some nuts from the inside of the torso. So that's one improvement. um, Second, as you can see on the back right away, there's a difference on the panel, right? So we actually got rid of the panel because we noticed that it's two steps. Sometimes you need to take out the panel in order to take out the big panel, and it kind of make it like hard to access the insides of the robot. So what we did is like we just put the power button and the charger accessible there. And when you take the big panel, the button and the charger actually stays in the same position. So you can just remove the panel and access everything. Whether in this situation, even if you remove this big panel, you still need to unscrew the smaller one just to take and disconnect some of the ports that we had here. So that's a improvement over there. Um, Second, maybe you can see the arms right away as well, right? If I move the robot, whoop, like this, you can see that the arms are a bit thicker on the new version. This is because we actually redesigned them a little bit. Well, not a little bit, it's a whole redesign. So these parts are totally different. Just to make it a bit more robust, we increase the thickness of this part, and we actually also change some of the internals here just to make sure that the parts fit better. And we had some kind of like issues, or like problems on the assembling side. Sometimes you had to put like a knot in this part, but if you already put the motor and you forgot the knot, then you have to start over the process. So now we actually make the parts a bit bigger and a bit thicker for allocate the heated inserts, so there's no problem. We don't have to worry about putting nuts here and there. Another improvement on the torso side, as you can see, now there is some ventilation holes as well, not only from the back panel but from the side panel. So now that we start to run, whole body locomotion, uh, things start to warm up, right? Like the CPU of the processor start to work harder, and we notice that we need some air just to pass through here. So that's what we decide to add some vent holes in the torso. Same case for the pelvis. Pelvis actually concentrate three of the bigger motors of the robot. We haven't had any problem, any warning of the motors overheating, but we just add some extra venting holes there, just in case when we have the robot running for longer. Um, what else changed? Oh, let me mention about the feet. So previously, we had the articulated feet. This is a change that we did, a couple of months ago. For people that already follow, will know that this is not a new thing, but it was not on the files, right? It was not on the design. So two big changes. There's no more toe here. It make it hard for us to manufacture this hinge at scale, and it was hard to simulate. And since it's a spring hinge, you need to tension it to the right value, which if you don't do it, then your simulation is not going to be exactly the same, and you might have problems there. Second is the feet are now symmetrical, so that make it easy as well for simulation. Like you don't have, certain uh, geometries that are not similar from one to another, and this helps a lot to have a like an even training and avoid any problems, whether like your robot is not walking properly because the geometry on one feet is actually different from the other one, right? So that's a change there. We actually decide to remove the front panels that covers the ankle mechanism. So now if you see it from the side, now there's just like a chamfer here. This is because it was an extra step to add the cover, and it didn't really add much value. So we just want to have everything accessible for anyone to just install it or repair it. And if you ask me, I think it also looks cooler just to show the bars over there. What else? There's a lot more changes inside of the torso. Let me see if I can just showcase that very quickly. Okay, so as you guys can see, this is what I mentioned. Oh, I took out the battery accidentally. Okay, I'll take it out. The battery actually houses both the button and the charger. So you don't have to worry about like taking another extra panel to do it. Um, we did some changes inside. So now there's some stoppers so the battery doesn't move around. And there is now some extra like space in here for wiring. That's hard to see. So there's like this square that allows to wire all the CAN communication that goes from the RPU all the way to the head and to the arms. So this is going to be helpful for wire routing at the end. On the arm side, also there was a physical stopper that was actually achieved by this plastic part over here on the elbow, but the motors are quite strong. So when we accidentally move the joints out of position and you smash the elbow back, it actually cracks. So instead of having a plastic stopper in this section, we now put it in the aluminum parts. And it's actually kind of cool how the mechanism looks like. Let me see if I can make this transparent for you guys to see. So there, maybe not this one. So there's this small pivot in this section, and the other part has like a channel. So now that when the elbow bends, the other part will hit inside the channel of this part. So the stopper, it's basically now aluminum versus aluminum. So that should help with the forces that the elbow generated just in case it moves quite abruptly. um so yeah, like those are the changes. There's probably a few more little details here and there, but that's going to be the overall. As I mentioned, we're gonna upload the new files in the GitHub soon, so you guys can access the new version of Asimo.
Right, thanks, Alejandro. So just a quick fact for everyone. So for all of our customers who are going to receive the Asimov 1 soon within September, all of the change has been reflected. So you actually receive the latest version, not the old one. So don't worry about that. Also on the manual, all of the assembly step is also reflected with the new design also. So yeah, um, thanks a lot. So the next one is Long. You can talk about Asimov emulator.
Hello, everyone. Okay, give me a second. Let me share my screen.
Yuki, actually, if you can see the Etsy camera, you see the robot and the stool, right? I think we maybe need to mention that later on we will also open source the stool that we use to, move Asimov and do some service onto it.
All right, yeah, the open stool. Okay,
Open
we're gonna
stool,
show you
yeah.
guys. Yeah, we're gonna show you guys the open stool at the end of this uh,
Yeah.
stream also.
It's
Yeah.
it's an easy way to sit down the robot, to put it in stand, do some servicing on it. Yeah. For all the people that actually don't have a crane, you can fabricate this just to have your Asimov sitting in a living room and just go up whenever you need it.
Hello? Can anyone hear me? Yuki, is okay? Is it okay if I start now?
Yeah, go for it. Go for it now. Yeah.
Yeah, sure. Hello, everyone. Thanks for having me today. So my name is Long, and I am on the platform team. So today I'm going to talk to you about what we've been doing at Menlo over the cross like 2 weeks. This was like one of the projects that we started due to the fact that we need to have some kind of pipeline that help us test the robot before we put the software and everything on top of the robots. So previously we were able, as you know, like we used to have something called try.menlo.ai, which basically allows us to run, provides you guys with an interface that controls the robots with the policy that we have on the web. But the problem with those kind of simulation is that it is not really close to the robot stacks, meaning that the software that we are running is simulated, meaning that there's no firmware, there's no actual like what we call azimuth edge that control the actual robot through the canvas. But now, like after a few weeks, we were able to get to a point that we can now emulate the entire stacks with the actual firmware, with the actual software, and allow us to test the robots from different tiers. What do we mean by different tiers? So like the lowest tier right here is the browser sim, meaning that there's no firmware, no software, no stacks or anything. But going up, you see that we will get closer and closer to the robot stacks until we get to this point where we can test with an actual phone, actual Pi, and actual RPU. And the only thing that's being emulated is the mobile side. So I can continue like showing you guys on the next slide on how those stacks is defined. So as you see in the real support, right, we have the clients, which is the Menlo app that you can use to control the robots later on when we ship the robots. And there will also be the platform side also, where with the client app will be calling the platform and also going down to the robot itself. The robot will be running the edge, which is like the one that is connecting to and controlling the buses, and we will talk the firmware itself. And then later on, the canvas will be mapped to the bodies. So you can see like when we look into the emulated bodies that we have been doing, we emulated the entire thing, and only the physical body individual is the simulated part. And in this one, we map the canvas from the that is controlled by the firmware into the actual motors that is being run inside the Pujuko environment. Here's like the other emulated parts that we've done, but and it is just a simulation, not an emulated emulation, since there's no actual robot running, there's no firmware, and there's no canvas. So here's also like another image which I have prepared so that you guys can have a look and understand what part is being run and what part is not being run. And with the Menlo Studio site that we have been doing, this part will not be released to the public yet. It will be used as an internal tool, but it's with the stack that's being run, we can easily speed up the each of the stacks that is being run here with just a few very simple comments. I think it's better for me now to show you like the demos that we've been doing, so that you can get a sense of how it feels like. So first, before I show you this demo, I have to first show you the one. Oh, what is it? Okay, let me try to drive it right now. Okay. So right here is emulated robots that we have been preparing, and now we are using an Android emulator connecting to the studio, which is what we have been doing. And now we can release it, and then we can try to control it to see if it works. Okay, if we release it, and as you can see, we can drive the bot. Oh, it falls because the canvas is failing. Sorry. Today, my laptop is not really good, but as you can see, like we can map the entire stuff, and we can emulate the robot to have it control over the laptop and have it run inside your laptop only. Uh, there should be another demo that I can show you guys. I think it's somewhere here. Here's the one, I think. Yeah. Here's one of the demos that I was running. That is running on the actual stack on the RPi, and we are mapping it so that we can control it through the phone, meaning that it's running the actual hardware, not the emulated one on the laptop. So it should be running much better. So the only thing that is being emulated right here is the Mujoku body, and we can use the phone to drive it and through the platform that we were using, and the actual stacks it's running on our actual hardware. So in the future, we can kind of speed it up as a few stacks of RPU, and as well as the and with the RPU and the RPI, and we can have it control the robots through the web like this. I think that's it for the demo, Yuki.
All right, awesome stuff. Thanks, Long. Yeah, so just a bit of context for all of our viewers out there. The point of Asimov emulator is that eventually everyone will be able to write application and then deploy and test software-wise before they ever need to actually hit the real, physical robot itself. For those who don't have a chance to purchase yet or thinking about it, this is where you can have your playground to experimenting with it, right? Yeah, in any case, thanks a lot, Long. That's really cool. Next up, we actually have from our brain side, Jiaqi going to show you guys about the latest development on locomotion policy. Yeah.
Oh, okay. So we are gonna run the latest locomotion. So right now you can see this is the robot that's seated down. Uh, so this is kind of like if you don't have a crane, this is kind of how you would develop on a robot. So right now, like the motors are off, they're not powered on, and the entire robot is just resting on this stool. We call this, I guess we call this the open stool. Okay, no, I call it the open stool. We haven't decided a name yet. But this is kind of like how you would kind of it's the starting point of you kind of developing the robot, right? So right now, I think Ishni is about to turn on the new policy that we have, the new locomotion policy that we have. And this is kind of done uh, uh, via like a UI, kind of like this, right? This is not the final form of it, but it's kind of like you can open it up in your browser after you connect to the robot, right? And then you should be able to kind of turn on and off things on the robot. Um, and I think we can show you kind of like what Alejandro mentioned, the new grill. So this is kind of like these are all holes. The microphone is inside. It kind of like will give you kind of sorry. Okay, yeah. We're about to put it on stand, but yeah, these are the grills for the microphone. Um, yeah. Okay, hold on. Let me show you there's the controller as well. Where's the controller? Mm, well, you took it. Okay. Sorry. There we go. Um, this is the controller. You can connect any controller you want. This is just our controller. The robot doesn't come with a controller. Any kind of like Bluetooth controller more or less works. Um, Okay, so you kind of turn it on via the controller after the robot is on, um, and then you can more or less, yeah, yeah. So mostly you can do it as a single person. Okay, so right now, by the way, the robot's standing. Um, you can just kick this away. No, it doesn't. Hold on. Nope, it's good. Yep. Okay, so robot standing now. Um, the other very good thing you can use the open stool for is you can push the robot with the open stool like this. Gonna try to get it balanced. Uh, huh? Whoa! Oh, that's okay. Don't worry about it. So that's the safety mechanism of the robot kicking in when the firmware goes into kind of like a unexpected state. Okay, hold on the camera for me. Thank you. Ah. So if the robot falls down, you can point the camera at me. If the robot goes down, you just have to put it back on this. All right. This is what happens when you test your locomotion policy live on the internet. It always goes wrong like within 30 seconds. But as you can see from the state of the robot, this is a fairly common occurrence, and kind of like we're looking for all the limitations and edge cases of the robot. This is a fairly new policy. So We haven't tested all of it yet. But yeah, so we can reset the robot now, and maybe we can use the one that is like more stable. Does anybody have any questions while we reset the robot? Yeah, I know, this demo curse. Oh yeah, okay, so a little about this. Oh, what did you do? Can you use the stable one? Okay, so
Getty, I think the
yeah,
test now becomes, like a drop test for the robot, so people
this
can see
is yeah, it's a
actually how
drop
robust
test
it is.
where the mechanical structure of this robot is fairly strong. Even despite all of this violence, the robot has not broken yet. Um,
We have some
which is
back
fairly
panels that
good.
are
Hold
broke
on, Alex, can you help
last
me hold the
time.
camera? I need, unfortunately, I need both hands to operate the robot. Hold on, Alex, point the
It's
camera at me,
okay.
please.
Take your
Okay.
time, guys. Don't
This
rush
is
it.
the value of the open stool, and this is what research is about. Okay. Yeah. So, okay. Can we use the normal policy issue instead of the experimental one? I think we're done testing the experimental one. Just use the normal startup procedure. Okay. Oh yeah, by the way, these are shoes. Um, you can actually just print this TPU however you like. Uh, they kind of help soften the footfall of the robot a little bit. They're fairly easy to put on. We've experimented with like using children's shoes. We haven't figured out how to do it yet. We got a pair here.
Yeah, so I guess
Yeah.
in the interest of time,
Oh,
we can move
yeah.
over to Richard first. So like while we're
Richard.
settling
Oh,
all of
yeah.
the
Sorry. Yeah, Richard.
yeah,
Please go ahead while we fix these problems. Yeah.
yeah,
All right. Sorry.
yeah. Don't worry, it's like a bit of intermission before setting it. Like yeah.
Sure, sure. Hi, I'm Richard. I am ML researcher. I get to do a lot of research on the side of my full-time job. I am not actually on the Asimov team, but I guess part of the community, right? Um, and so I wanted to basically train a general motion tracking policy for the Asimov. And I'm following this paper called Robust and Generalized Human Motion Tracking. And their platform was the Unitree G1. And this paper doesn't have any code or data published. So I went and had to, basically follow this paper with the help of Claude Code and bring it to code, and also created a data set. And so this paper references that they use a 3.5 hours of data, and this is animation data that was retargeted from AMAS, which is a widely popular data set for humanoid motions. And they retargeted it for the G1, but of course, in my case, I'm retargeting it for the Asimov. Yeah, I'm RSAMF. I live in the simulation channel, so if you ever see me, that's where I am. And I occasionally like to report stuff that I am doing. I have a lot of work in progress that I like to report there. So basically, the gist of this policy that I'm training is it takes like a reference motion and outputs plausible actions that can be performed in a regular real world, like a physics environment. Of course, I'm only working in physics sims because I don't have the Asimov yet. And so I'm using the Newton physics sim. But nonetheless, I have 8.5 hours of data that I'd like to share with the rest of the community. And so I am also sharing this web application where you get to explore this data set. And I can share the links with you all in the chat, or actually I'll do that after in the Discord. So this is right now currently deployed on Hugging Face Spaces. You can look around and see all 8.5 hours if you want, but you can also filter it. And what I decided to do is I decided to split the data set into 3 difficulties: easy, medium, and hard. And you can actually look through here, and this is just for this test split, but yeah, so this is the entire data set. There's 3 different difficulties: easy, medium, and hard. Currently, I have trained just on the easy and medium data. I have done also previous experiments on easy, medium, and hard, all data clip, all motion clips, but I wanted to just do the easy and medium ones because some of the hard ones are pretty hard. Let's see if I can find one that's pretty difficult. So these difficulties are based on a few factors like saturation, joint limit saturation, which is basically how much of the time a joint limit is reached, and like root velocity and root angular velocity, a lot of different factors, and it required a lot of my time to basically filter out a lot of the impossible motion clips from this data set. And a lot of that was possible by training a policy first to see like which clips are basically unachievable. And I was able to use this clip explorer to basically get feedback on what my policy was unable to do most of the time, filter those out. And a lot of those clips are like basically that Asimov, like going upstairs when there's no stairs, of course, because a lot of the AMAS data has a lot of clips of the reference character going upstairs or doing parkour and stuff that would just be impossible. Or like I also filtered out like cartwheels, the robot lying down. Yeah, a lot of that data is unwanted. And so now I want to share this data set with you all. It's on GitHub. I can't actually publish the retargeted results to you guys. You'll have to clone this GitHub repo and run the retargeting yourself. The reason I can't like publish the actual outputs is because of the licensing issues with AMAS. I can't deliver derived results, but I can give you the code so you can run it yourself. And I also wanted to share my personal project, which is Nebo. It's an agent native experiment tracker. This is, if you're in my world and you do like a lot of ML research, you might be aware of TensorBoard, weights and biases, or ML flow. There's a lot of experiment trackers out there, and I thought it was time for like a modern one in which I can not only track experiments, but also visualize like vision pipelines, like this is a little sneak peek of what's coming in Nebo. I'm going to have like a robotics extension because that's particularly what I'm working on. You can see like results of your policy. Let's play this. There we go. So and the blue is the reference motion and the orange is my policy. So this is a motion that the policy has never seen before. Like this type of gait was never seen before. And so this is an example of my policy performing it in simulation on the Newton physics sim. And this is just replaying that motion. And this will be useful for things like, of course, locomotion, like I'm showing you, but also for object manipulation tasks, like, for example, the robot walking and also moving a tray around, like a tray of food for food delivery. And there's a lot of more things to talk about in Nebo, but one of the things that I'd like to that I think is my favorite is that it's mobile first, and so you don't have to be at your desk while monitoring metrics. That's one of my biggest pet peeves about like all the experiment trackers today. You can't walk away from your desk when there's a long training run if you want to like look up metrics live. You have to go back to your computer and do it. But this is a mobile first viewing. Yeah. And that's all.
Right. Cool. Thanks, Richard. Yeah, it's very cool. I mean, like seeing Asimov being able to do so many, it's like interesting motion. Yeah, like that's the first time we see outside of Menlo. Actually, that's really great work you have done. And thank you a lot for also coming on to our stream. So I think we are back with live from Jachi. So like now we have the policy running. So I will give the stage back up to Jachi. Yeah.
Okay, yeah, sorry guys. No more live testing of experimental code. Let's just show you guys the walking first. So can I, yeah, so Rishi is now using the controller. You can see it in his hand. So you use kind of like these joysticks to move the robot around. And yeah, this is the stable policy that we've been working on. You can see there's a huge difference between the experimental one and the live one. Can you lend me the controller? Okay, so over here on the right side, this is like rotation. Can rotate around. Um, yeah. So one of the earlier problems with this one was that no, stop rotating. Okay. Don't hold on to the robot. Yeah. Okay. Yeah. So that was yeah. So let's show you the robot kind of like walking forward and backwards. We've kind of yeah, we've been speed testing it, and this is kind of like on the slow mode. So we can do left and right as well. It's kind of nice on the left and right. Okay. Yeah. Okay. So that's it for today. We probably have some repairs to do. But yeah, maybe we'll give you guys another update quite soon.
Right. Thanks, Jachi. Okay. Next up, Embry, do you want to talk a bit about our social?
Yes,
Yeah,
let
social
me
media.
share my screen. Up. Okay, where's this? I think it's here. Okay, hey everyone, and thanks Richard for sharing his updates, by the way, really appreciate it. And we have been seeing some really cool things coming from the community over the last few days, so we wanted to share a few of them together with some Asimov updates during this live stream. And first thing first, we have some good news. You can now order Asimov 1. There's no pre-order anymore. Just check menlo.ai and you can order your Asimov 1 directly. There's no pre-order. And we are still improving the page and the overall ordering experience. So if you have any questions or feedback, please send them our way on Discord or here. And it's really useful for us, especially at this stage. We are still improving and optimizing things. And we are also working on another launch right now. We have made a lot of progress on Sim2Real for Asimov, and we will have a dedicated announcement around that very soon. And if you guys follow our social media channels, we are sharing a lot of cool community updates. I mean, I believe we have a really good community, and this one is really cool. Dylan took the open source CAD files for Asimov 1 and built a full robot configurator around them. He even used Opus 5 to experiment with materials and different poses, so you can use your own agents to build something on top of Asimov 1. And apparently, the next challenge is hands, as he mentioned here, because those weren't part of the CAD files. This is exactly the kind of thing we love we love seeing people build on top of Asimov. And we will also have good news on this site soon, and we will be doing another announcement for the hand site. And we are adding one more degrees of freedom and gripper as an add-on to Asimov 1, and details coming soon on this site. And we also have another cool project from the Drift team. And they built the warehouse simulation environment that Asimov was trained in for the carton flipping experiment, the conveyor, shelving, and the whole surrounding environment. What I really like about this is that they didn't need to touch our RL stack. Different teams can work on different parts of the ecosystem by just checking our files, by just checking all of the things we shared with the community, and they can still build something useful together without checking with us. And we are planning to work with them closely on this one, on this project, and we will share another announcement for this one as well. And for the other side, actually, I would like to highlight that we are also seeing more people independently writing about Asimov and explaining the projects to their own audiences. This post was from Simplifying AI. They went pretty deep into the hardware, CAD files, schematics, simulation model, and the idea that people can actually build the robot themselves. And we are seeing a lot of posts like this, and we really appreciate your effort to share Asimov and Menlo Research with your own words. And we are promoting these projects on social media channels. If you guys would like to see the projects that built on top of Asimov and Menlo Research solutions, just check Asimov Inc. and Menlo Research social media channels. And I think we don't have enough time to highlight all of them, but we see a lot of cool things here. So the overall, we are starting to see new projects, new experiments, and conversations happening around Asimov without us being directly involved. This is the thing actually we want to do, which is great. What we would like to build at Menlo is to build an ecosystem that awesome projects and companies start their own journey. So that's something we want to see much more of, and we really appreciate your efforts here. If you're building anything with Asimov or any Menlo Research solutions, even if it's early or experimental, just share with us, ping us on Discord, social media channels. We are checking all of the messages on social media and Discord. Just ping us, and we would love to see it more and work together. Thank you so much. That's all. Back to Yuki.
Right. Thanks, Emre, for the updates. And so at this point, I guess we can start to invite Herman to talk a bit about our career. Herman?
Hi everyone, very nice to meet all of you. Yeah, so my name is Herman. Very nice to see all of you guys again. So I hope you guys can see my screen. I think right now we have a couple of roles still open and we're hiring for. I think someone we're really looking for is a marketing lead in our APAC. So ideally someone who's based in Singapore. If this fits your bill, I think just drop me a DM on Discord or even on LinkedIn. Let's link up, let's have coffee and then talk over notes. Yep, the other roles that are also priority for us are on the website. So I look forward to receiving your applications and talking to you guys soon. Thanks so much. Yuki, back to you.
All right, thanks, Herman. So I guess that's it for the stream for today. Thanks you guys a lot for sticking around and sees all of the upcoming development as well as the progress that we have made on Asimov. We are very glad to always have you guys on the journey. We'll stay for around 2 to 3 more minutes, just in case anyone have any question that we can answer. Okay, if not, thanks you guys a lot for joining us for the Community Friday again. And we are really excited for the next one to come. Right. So see you guys next week.
See you next week.